For more than a decade, astronomers waited for this moment. They weren't simply hoping for another breathtaking image of distant galaxies or colorful clouds of gas. They were waiting for the first pieces of a project unlike anything ever attempted. A map so vast that it could reshape our understanding of the universe itself. This isn't a map of continents or stars. It's a three-dimensional chart of billions of galaxies spread across more than 10 billion years of cosmic history. Hidden inside that immense structure are clues to two of the greatest mysteries in modern physics: dark matter and dark energy. Together, these invisible components appear to control the evolution of the cosmos, yet neither has ever been observed directly. On July 1, 2023, the European Space Agency launched the Euclid Space Telescope aboard a Falcon 9 rocket from Cape Canaveral. Its destination was the Sun-Earth Lagrange Point 2, or L2, a stable region of space roughly 1.5 million kilometers from Earth. From this quiet gravitational location, shared by missions such as the James Webb Space Telescope, Euclid can observe the universe with exceptional stability, free from many of the disturbances found closer to Earth. After months of testing, calibration, and careful preparation, Euclid finally opened its eyes to the cosmos. The first images were more than beautiful, they were scientifically remarkable. Astronomers saw enormous galaxy clusters packed with extraordinary detail, revealing countless galaxies both near and far. They identified hundreds of previously unknown dwarf galaxies within the Perseus cluster. They captured an ancient globular cluster with impressive clarity in only about an hour of observation. They also surveyed famous regions like the Horsehead Nebula while detecting numerous faint objects that may include free-floating planetary candidates. Each image demonstrated something important: Euclid is capable of combining a huge field of view with exceptional image quality. Instead of choosing between seeing a small region in high detail or a large region with lower resolution, the telescope can do both simultaneously. That capability is exactly what scientists have been waiting for. Unlike most observatories, Euclid was never designed to focus on a handful of spectacular objects. Its primary mission is much larger. Over the next 6 years, it will survey roughly 1/3 of the entire sky, measuring the positions, shapes, and distances of billions of galaxies. Some of the light reaching Euclid today began its journey more than 10 billion years ago. Every distant galaxy therefore acts like a snapshot from another era in cosmic history. Looking farther into space also means looking farther back in time. Nearby galaxies reveal what the universe looks like today. Extremely distant galaxies reveal what it looked like when it was still young. By comparing galaxies from different epochs, astronomers can reconstruct how cosmic structures formed and evolved across billions of years. That makes Euclid something far more powerful than an ordinary telescope. It is, in many ways, a machine for studying the history of the universe. But mapping galaxies is only part of the mission. The visible universe represents just a small fraction of everything that exists. Stars, planets, and glowing gas account for only a tiny percentage of the cosmos. Most of the universe appears to consist of dark matter, which exerts gravity without emitting light, and dark energy, the mysterious phenomenon associated with the accelerating expansion of space. Although invisible, these components leave measurable effects. Galaxies do not scatter randomly across the universe. Instead, they gather into enormous clusters connected by vast filaments, creating a structure astronomers call the cosmic web. The gravity of unseen matter appears to play a major role in shaping this gigantic network. Euclid was built specifically to investigate these hidden structures. One of its most powerful techniques involves measuring incredibly subtle distortions in the shapes of distant galaxies. As light travels toward Earth, gravity from massive objects along its path bends that light slightly, a phenomenon known as gravitational lensing. Even when the matter responsible cannot be seen directly, its gravitational influence can still be measured. By studying millions of these tiny distortions, Euclid allows scientists to create detailed maps showing where invisible mass is likely concentrated throughout the universe. The telescope also carries advanced near-infrared instruments capable of measuring galaxy distances through their redshifts. Combining this information with precise imaging enables astronomers to place galaxies within a true three-dimensional framework rather than a simple flat picture of the sky. Instead of producing another beautiful photograph, Euclid is assembling an immense cosmic atlas. One that reveals not only where galaxies are located, but also how gravity has shaped their distribution over billions of years. The first observations already hint at the mission's enormous potential.